Hello everyone. This week's lab is Molarity and Dilutions of Solutions. Hopefully you've read the background material. I'm going to go through the experimental procedure now. So the first step is to weigh your 100 milliliter volumetric flask. And we have 62.0772 grams. And I have pre-weighed some copper sulfate here in the weighing boat. It's a little over 3 grams. We will check that again once I get it all added here. And we have a new weight of 65.7651. So you'll subtract the weight of the empty flask from this weight to get the weight of your compound. And now it says to dissolve this with distilled water. I have 50 mils here to get this started. This amount here is arbitrary at this point. And we'll just make sure we get this all fully dissolved. This may take a little while. It looks pretty good. And now we'll just add more DI water until we get up to the line on the flask. Okay, I'm at the line now. So I filled this to the line marked on the flask. I will shake this again to make sure it's completely mixed. And this now is our stock solution. And now we need to determine the percent transmission of light through this solution. So if you look at your table 1 here, it tells you that for copper sulfate, we want to use 625 nanometers on the spectrophotometer. I've already set this at 625. And we will transfer some of this. Well, first of all, we need to blank the instrument with DI water in the cuvette, and that's where I put my cuvette. It's in there. Okay, so we fill this about 3/4 full with distilled water first. We put this in the spectrophotometer, close the lid, and we will hit the 0 button here and give that a minute, and it should come to 100% transmittance. Now we can dump out the distilled water, and we will fill this with our solution. That back, and we now have 50% transmission. So you'll record that as your percent transmission for the stock solution. And we can move on to part B, preparing dilutions, measuring transmission, and creating calibration graphs. Clean 4 50 ml volumetric flasks and label them 1 through 4. I have those ready here. I have volumetric pipettes already pre-cleaned and rinsed. These are ready to go. So for flask number 1, we will use 5 milliliters of the stock solution. So we take our 5 ml volumetric pipette. These have a marking here where it's at 5 milliliters. This is a pipette bulb. Let me get this out of the way. When you use a pipette, never force it down on so the pipette is hanging from here. That is not the way to use these. You will squeeze the bulb and apply only enough pressure to create a seal there, but don't force it right on there. So what we'll do is we'll put this into the solution, and then you release the pipette bulb to create a vacuum, and that will bring the solution up part way. If you don't get it all the way up there on the first try, you can just squeeze the bulb and do that again. Now, see, I've got my thumb on top here to control where this is, and I will stop it right there. It stopped at the line. I will put this into flask number 1 and just let it drain in there. You don't need to use the bulb to squeeze the liquid out of there. It's calibrated so that it delivers the 5 milliliters. So we have 5 milliliters in here now, and I will fill this to the line. Again, find this line that's very difficult to see. Okay, it's right there. Okay, and that's at 50 milliliters now. And for flask number 2, we use 10 milliliters. So I have a 10 ml volumetric pipette. Okay. There's 10 milliliters into flask 2. I'm going to get some PI water in a graduated cylinder rather than using that squeeze bottle each time. This will go a little quicker. And once I get close to the volume I need, I will then switch to this so I don't go over the line with it. And there's our 50 mils of solution 2. Solution 3, use 15 milliliters. Here's the 15 milliliter pipette. Into flask number 3. And in flask number 4, we need 20 milliliters. To add the water to those last 2 I did. Okay, there's our 4 solutions prepared. And now, each one of these solutions, we need to measure the percent transmission. So here is solution 1. And this one's diluted quite a bit, so we should expect more transmission through this one. So this is measuring the amount of light that goes through the solution. And the more concentrated the solution, the less light will get through it. So we expect the dilute solutions to transmit more light, and the more concentrated ones to transmit less. So you can see that this solution 1 is 92.6% transmission. Solution 2 is 86.9%. Solution 3 is 79.9%. And solution 4, we have 75.4%. This, you'll be preparing a graph using Excel. You can read the procedure for doing that. I'm not going to do the graph right now. That's something you can do on your own from this experimental data. So I'm moving on to part C, performing serial dilutions. So in this first part, we used the stock solution each time. For each of these 4 solutions, we started with the stock solution. In this next part, we're going to start with the stock solution for the first one, but then each one after that, we're going to use the one that we just prepared in the previous step. So this will be a serial dilution. These are labeled 1 through 3. I guess it was actually supposed to be A, B, and C, but that'll be fine. Solution A, which we have number 1, will dispense 20 milliliters of the stock solution with a 20 ml pipette. So here again is my 20 ml pipette. I'm using the stock solution. Put that into the first flask. And fill this to the line right there. And we'll shake this up. So for solution 1 or solution A, we have a transmission of 55.3%. And now to prepare solution B, it says to dispense 10 milliliters of solution A into the next flask. So starting with solution A that I just made, we'll get 10 milliliters of that. And we'll put that into flask B. And again, we'll fill the flask with water up to the line etched on it. Invert it a couple of times to make sure that's mixed. And again, we will measure the transmission of this. This one is 77.8% transmission. And finally, we will prepare solution C, starting with solution B that we just made. So again, we'll take 10 milliliters of solution B. So you can see each time this is becoming more dilute from what it was the previous one. So we should expect transmission to keep increasing. Go. And the transmission for solution C is 89.2%. And that is it for the experimental procedure of this. You will be doing calculations. You'll graph the results you got in part B and then use data from that to figure out your molarities for part C and so on. But that is it for the experimental part of this procedure. Thank you.